Okay, so if you want to insert an object into a tree set, so a tree set, just to recap what a tree set is. What the tree set is a tree set is going to, first of all, it does not allow duplicates. It's a set. The tree word means they're going to be organized. So if you have a tree set of integers, okay, so if I put in the numbers 4, 17, 3, and 1, okay, if I put those four numbers into a tree set of integers, it's going to organize them by 1, 3, 4, and 17. Okay, that's what a tree set does. A tree set puts them in an order. How does it know the order? It knows the order because only classes that implement this guy, the comparable interface, can be inserted into a tree set. Okay, so all of the wrapper classes implement comparable. The string class also implements comparable. String builders also implement comparable. Okay, so only classes that implement the comparable interface can be put into a tree set. We have a tree map. Okay, so it's a map. So if it's a map, that means you have a key and you have a value. Okay, the key has to be unique. The value can be repeating. Okay, so how? So when it's a map, the key has to be unique. How does it know unique? It knows it's unique by the hash code in the equals method. Okay, and also a tree map orders them by key. How does it order them by key? The key, whatever the key is. So it can be an integer, it can be any number, it can be any object. Okay, it has to be an object that also implements the comparable interface. Okay, so tree map, it's the keys in a tree map also have to implement the comparable interface. All right, now, so this is what this lesson is about. Now, I said something wrong yesterday. Okay, so I'll explain the comparable interface first. Comparable interface is one method. Okay, compare to. All right, compare to returns an int, and it takes an object of type t. So, for instance, we're going to have a rat class that's going to implement the comparable interface. The way it's going to work, so we will have rat implements comparable. Now, you can see comparable takes a generic. So usually when we're implementing, when a class is implementing a interface, we give it a type. All right. So that means that the compare method, and sorry, it's not compare. It's compare to. Stand corrected. It's compare to. Okay. It's compare to, not compare. Okay. So when your rat implements comparable rat, that means the compare to method is going to read int compare to, and it's going to be rat arg 0. Okay, so usually when you're implementing the comparable interface, you supply it with the type. All right, now what is compare to used? It's used to compare the object that's calling. So for instance, rat. Okay, we're going to have one rat. So this rat, so let's say a rat is called Ronnie, is going to comparing it against another one called Rory. Okay, so that's what's calling a method. That's what's been sent to the method. So it's comparing two things, and both hash set and hash map, that's what it used to determine order. Okay, now, so comparable is a functional interface, so we can create lambdas in the interface. Now, there is something called comparator. I was wrong yesterday what I said. Okay, comparator is a separate interface. Okay, that has a compare method. All right, so comparable uses compare to, and that's what hash set and hash map uses. Comparator, now you use comparator to create comparator objects. All right, you use comparator to create comparator objects. Comparator is usually used with this guy, collections.sort. Okay, now comparator is used for collections that do not implement the comparable interface. Okay, so if it doesn't implement the comparable interface, what you can do is you can use a comparator in conjunction with this to sort a list. Okay, that's what a comparator is used for. But first we're going to show you comparable. Okay, we're going to show you the comparable interface and the method compare to. Okay, so I'll show the example here of two strings. Right, so string 1 compare to string 2. Now the string class has a compare to method. All right, the compare to method of the string class goes on alphabetical, so it's going to be symbols first, then numbers, then uppercase, then lowercase. Okay, that's the order: symbols, numbers, uppercase, lowercase. I am, yeah. So now, so compare to returns an int. Now, if apple compare to apple, if they're both the same, that's going to return 0. All right. Now, that means a couple of things. That means if it returns 0, that means it's not going to be added to the hash set, or it's not going to be added to the hash map as a value. Okay. So that's how it knows not to put in a value. It checks it to see if it's already there. If it is, it won't go into the hash set, or it won't go in as a key in a hash map. Okay, so it's the same. Now, if if this string, so A, comes before this string, which is B, then that's going to return a negative number. So that will return a negative number. All right, so apple compared to berry, that will return a negative number. That's if that letter A comes before that letter B, it does, so that's going to give us a minus number. Now that's actually going to give us -1, I discovered yesterday. That's the difference between them. So if you had Z, it'd be apple compared to Z, Z-E-D, that would give us -26. All right. Now, so this one, we have berry. So this is B. So berry compared to apple. Okay, so B comes after apple. All right, or another way of putting it, B is bigger than A, which we're going to be doing as well when it comes to numbers. All right, so B comes after A, that's going to give us a positive number. Okay, so this is an example. If they're both the same, it's going to give 0. If this guy comes before this guy, it's going to give a negative number. If this guy comes after this guy, it's going to give a positive number. All right, so that's how it compares objects. All right, so we then went down here and we did a couple of them. So, strings. Make sure that's done. So, I have A comes before Z. All right. So we get a minus number. Okay. B comes after A, so it gives us a positive number. B returns a 0 number. All right, just going to quickly do another one or two of them. So if I do this one, I do Adam dot pair to now. Is that going to return a positive or a negative number? Capitals come beforehand. Okay, so that's going to return a plus. Okay, so yeah, because Z comes before, that's capital Z comes before A. Okay, so this returns a positive as, put it here in a separate line, returns positive as capital Z comes before lower case A. Okay, so returns positive as so we can see here Adam compared to Z, that one comes before that one, so it's going to be a minus. Okay, that guy comes before that one, so that returns a positive. They're both the same. That guy returns before that one, so it returns a positive. Okay, now, so now you can't use null with compare to, by the way. All right, you can't. I don't know if I said this already. You can't put null in a tree set as a tree map. All right, you can't put null in a tree set. Why do you think? Just to prove that you can't. Watch. So let me just. I'll quickly create a set integer, and I'm going to call it my set is equal to new tree set. No, sorry, they're not comparable. Okay, let me just show you. All right, only something that can be compared can be put into a tree set. You can't compare a null with a number. You can't compare a null with a string. All right, it doesn't go before or after because you can't compare it. It's like trying to compare a cat with a bank account. They're two totally different things, right? So something has to be comparable. That's what an interface is. All right. If I try to add a null to show you, so if I go my set dot add null, now that should give us, there it is, null pointer exception. Okay. Okay. So can't add null, so can't use compare. So here we go. Can't use null with compare to, as null is no value, and you can't compare nothing with something. All right? That's nothing. I don't know what nothing is. No difference. No. Doesn't matter what it is. No, it's because they're just incompatible types. Okay? Because in order for you to compare to something, it has to be something. It has to have some value. Null doesn't have a value. All right. Um, I'm not too sure now, Jason, because we're going to be doing ones where we do take into account null and ones that we don't take into account null. So my answer to that is I don't know. I imagine it would be, even though it's still not going to be able to take it into account. Okay. As null has no values, it can't pair nothing with something. Okay. So it doesn't matter what compare to you use, you can't put it at it. You can't use a null with compare to, right? If you can't use a null with compare to, so if you can't use null with compare to, that means you can't add null to tree set or as a value in a tree map. Now, it not as a value, as a key. It's a key. It's a key. It can be a value, right? You can have null values in a tree map. Nothing wrong with that. But you can't have a key that's null. Going back to databases, if you remember databases, lads, remember a primary key. Can a primary key be null? You can't have a null primary key. Same rule applies here. Okay. So this will generate a null pointer exception. Right, so take that out. Now, so I am going to create, let me just see. So I'm going to create integers. Okay, so I'm going to go integer 1 is equal to 1. Integer 2 is equal to 2. Integer 22 is equal to 22. And integer minus 5 is equal to minus 5. Now, integers can be minus as well. Okay, so excuse me. Oh, Jesus Christ. Right. So compare to works exactly the same way here. So if we have 1 dot compare to 2, the difference between the two of them is minus 1. Okay, so I'm just comparing integers. So 1 comes before 2, so the difference between them is minus 1. If I go 22 dot compare to compared to 1. That gives us 1. Now, when you're comparing numbers, right, it always only returns, as far as I know, -1, 1, or 0. When you're comparing strings, there's a lot more complicated stuff going on there, so it's going to produce a more complex number. All right. As far as I know, with integers, when you're comparing integers, if the first one is less than the second one, it's going to return -1. If the first one is greater than the second one, it's going to return +1. Now, as far as I know, I'll just try that with other ones. So if I go 22 that compare to -5. Now it should give us 1, I think. Yeah. Okay. So as far as I know, with numbers, you're comparing numbers, it's going to give you -1, 1. And with the two of them the same, it's going to return 0. All right. So the first one less than the second one, minus. The first one greater than the second one, plus. Okay. And it'll be -1, 1, 0. Now, it's important to remember that these are integers, not ints. Okay. These are integers, not ints. Right. Primitives don't have methods. All right. Now, what we're going to be doing is we're going to be creating our own compare to methods. All right. And what we're going to be doing inside our own compare to methods is, let's say if we have an age of something, we're going to be using the integer compare to. If we have the name of something, we're going to be using the string compare to. So we're always going back to one of these guys. All right. So we're going to use what's already there. Okay. Is everyone with me so far? Yes? Okay. Now, that's how it organizes. That's how it organizes tree sets and tree maps. All right. It checks. It's going to put it in. It'll see there's 1 in the list. It's 3. It's going to put 3 after 1. We have 2. It's going to compare it against. So let's say I'm putting in the numbers 1, 3, and 2 into a tree set. Okay. So it puts in the number 1 at this position. Okay. Then we put in number 3. Puts it in at the second position. How does it know to put it in the second position? It puts it in the second position because it compares 3 dot compare 1, and that's going to return a plus number. If it's a plus number, it knows to put it at the end. Okay. Then I go to put in 2. Now 2 is compared against 1. It'll see that 2 is bigger than 1, so it knows it goes after 1. It's going to compare 2 against 3. It sees that 2 is less than 3, so it's a minus number, so it knows it goes before the 3. So minus means it goes before, plus means it goes after. That's basically it. Okay, so I'll say that again. Plus means it goes after, minus means it goes before.
1 and 3, so it still be in same place always.
No, not always. Okay, so there's 1, 2, 3. Okay, there we have. Now I come along with, right, so we'll use slightly different numbers. 2. Okay, so right. So puts in 1. Fine. Now take out these positions. So it does 1 is put in. Fine. Then it goes 1 compares to 3. It says, so we have this number that's calling it is less than this number. So the outcome will be a minus 1. So minus means that goes, that 1 is at the, sorry, the other way around. Sorry, other way around. Sorry. Start that again. Okay. 1 is put in. Doesn't have to compare against anything. 3 is put in. So that is 3 compared to 1. Okay. 3 compared to 1, that will return a plus number, because that number is bigger than that number. If it's a plus number, it'll go after 1. All right? Fine. So far, so good. Doesn't have to do any more calculations. Next thing it does, it goes 5 compares itself to 1. It knows, so it checks 5, 1. That will give us a plus number. So it knows it goes after 1. Okay? So it says maybe it goes in here. Then it does 5, checks itself against 3. That also gives a plus number. So there's no other numbers in it, so it knows 5 goes after 3. There's no number after that, so 5 goes at the end. Now, the next one. 2 compares itself to 1. Again. All right. 2 compares itself to 1. 2 is bigger than 1. So that means it's a plus. So I can put itself in here. Now it knows. Next thing, it checks itself in the next one on the list. The next one on the list is 3. 2 compared to 3 gives us a minus number. So it goes in there. It doesn't have to check 5, because it already knows that 5 is bigger than 3. That's the way it works. All right?
So minus is like more important.
No,
minus, like
not
what need to check all the rest.
Not necessarily. That's just the way it's written. All right? It's the most mathematically efficient way of doing it. Mightn't seem like it with only 4 numbers, but when you get to thousands of numbers, it is. Okay? I wouldn't go saying minus is more important. That's just the way that list comes out. All right? So it gives you 1, 2, 3, 5. Now strings operate the exact same way. It's easier to show you that with numbers than with strings. But that's the basic concept of what we're doing. All right? So you're producing numbers. Minus numbers means it goes before. Plus numbers means it goes after. All right? So if you remember that, minus at the before, minus equals before, plus means after. Now, 0 means the same. All right? Now, 0, if it's 0, that means it won't be put into a tree set. It won't be put in as a key in a tree map. Okay? Now, but it doesn't always mean that it won't be put into a collection. Okay? There is circumstances when it can be 0 and it will be put into, now it won't be put into a tree set. It won't be put in as a key into a tree map, but it can be put into a list, right? And that's not so good if that happens, all right? Now, the main things about this is trying to avoid that situation happening, because we're going to, fuck you. And sorry, I'll beep that out in the video. Okay, so I'll just send you a quick invite again. Must say it. Ah, yep. Yeah, yeah. Well, we're going to have a compare to method in dog. Okay. Now, if there is no compare to method in dog, that means you can't add it to tree set, or you can't add it as a key to a tree map. Okay. But it can use these comparators, which is a custom made object that'll sort for you. So I'm going to add us all to invite Gmail. Add everyone to it. And Merrick. And right, so give it 20 seconds. Talk about it, talk about it. So, a couple of seconds, should be there. Now, so yeah, that's so. Could you all just add yourselves there? Right. So might as well do a new. Yes, could you add yourselves there? Right, so I'm going to go on and create another static void ex2. What we're going to do is we are going to put in here s1so rat class implements comparable. Right. So we go to the rat class. I'm going to go to the rat class. The first thing I'm going to do with the rat is I'm going to give it variables. Now, here's the thing. When we're implementing the compare to method, you really also, in an ideal world, should also override the hash code in the equals method as well. Okay? So if you're going to use compare to method, to make everything work like it should, like you want it to work, you should also always should override the hash code and the equals method, and you'll see why in a minute. All right, so just put in here, if you are going to implement comparable interface and have a compare to method, you should also always override the equals and the hash code method. Because remember, when you want to add to a hash set, what determines if something's already in the hash set is the hash code method, or the hash, okay? So that means you can't, well, if you want to add to a tree set, you really need to override the hash code method as well, all right? If you don't, it's going to take its equals method and its hash code method from the object class, all right? Now you can do it without it, and we are going to be doing it without overriding the equals and the hash code method. But by doing that, you'll see what can happen, what can go wrong. All right. So first thing we're going to have now, we're going to have the name of a rat. Yeah, I haven't put it in yet now. I don't want to put it in yet for a minute now. Okay. Now, so another thing, if we wanted to have all rats to be unique, I would put in some unique identifier, such as a ID, which would be different for every rat, but I don't want to do that. Okay, I don't want to do it in this circumstance. Now, I'm going to use an integer, and I'm going to use a double. Now, the reason I'm using these here is because we are using wrappers instead of primitives. So we can use the compare to methods of the integer and double class. Now, so you could also use primitives here, but when using compare to, we would have to use them in conjunction with wrappers. All right. Now, inside our rat compare to method, it's going to be using, so first of all, it's going to try and sort by name, and it's going to use the string compare to method. Okay. If they're the same name, then it's going to compare by age. It's going to use the integer compare to method. If they're the same name and age, then it's going to organize them by weight. Okay, and it's going to use the double wrapper compare to method. Okay, so if you have them as wrappers, it cuts out an extra step you need to do. All right, you can still use primitives. All right, because remember they're auto boxed. Remember that. But inside the compare to method, I'll show you what I mean. I'll show you when I come to the compare to method. Okay, now, so first thing we're going to do is we're going to override the hash code and we're going to override the equals method. Okay, so I go source And I'm just going to use what Eclipse gives us. Generate. Generate hash code and equals. They're fine. I'm not going to go through the explanation of those. You should know them by now. All right. So now our class is ready to implement the comparable interface. All right. You do all that first before you implement the comparable interface. So we're going to go up here. So public class rat implements comparable. If I don't put in a generic, let me just show you what happens. I go here, add unimplemented methods. Okay, you can see compare to is down here. Now, if I do that, you can see it's comparing itself against an object. That means inside here, I'd have to cast this object to be of type rat. To get rid of that step, all right, to get rid of that step, all we have to do up here is we say what type we're going to use in the compare to method. So we're comparing a rat against a rat. So public class implements comparable rat. The type for the compare to method is going to be rat. So if I go here, add on implemented methods, you can see now that this guy here is a rat. All right, it just means we have to do one less step inside here. All right, so I'm going to call this other rat R. So a rat is going to be calling this method, and it's going to be sending another rat to it. All right, so what are we going to start on? Up here, I'm going to say we're going to range rats by name, then age, then weight. Now, if they're the same rat, they are going to return 0, and they're not going to be inserted into a tree set. They're not going to be inserted into a tree map. Okay? So if they're the same, they're not going to be inserted into a tree set or tree map. So that's the first thing we need to check for. Okay? So I'll just leave return 0 down here for now. So the first thing we're checking for, put in the comment first. If same rat or all have same name, age, and weight. If same rat or the same race, will return 0. So our compare to method is going to say, it's going to call this equals method. All right, it's going to call this equals method. And if this equals method says that they have, if it returns true, now it will return true if they're the same rat. It'll also return true if they have the same age, name, and weight, even though they're different rats. Does everyone understand that? Yeah? So they're going to, so if you have twin rats, if you have clones, it will not put clones into a tree set. It will not put clones into a tree map. It won't put them in as keys. Okay? So in here, clones, which are different rats, but all same values, will not be inserted. Now, that's why I said at the start here, if I wanted to make sure that every rat was unique, I'd put an ID up here. And the simplest way to give an ID to something is have a counter. Okay? Now, I don't have a constructor inside the rat class either. I did that intentionally. Okay? I don't have a constructor inside the rat class. Yet, anyway. Okay? Now, so I'm going down to the compare to method. So I'm going to go if this. Now this is going to be the rat that's calling it. So our rat that's calling it is called Ronnie. Okay, and it's going dot compare to Rachel. Okay, Ronnie dot compare to Rachel. So this refers to Ronnie. This is calling it. So if this dot equals, now here I have it called R. Shit. Now, so if this dot equals R, so that is Ronnie that's calling the method, sending Rachel to it. If so, what it does then inside that, it goes Ronnie dot equals Rachel. Okay, if that returns true, it's going to return 0. If it returns 0, that means compare to means they're the same, means it won't be put into a hash set. Sorry, it won't be put into a tree set. It won't be put in as a key in a tree map. Okay? Yes? Everyone been so far? Grant. Right. So if same rat, same age, we return 0. That's that fine. I just go down here as well. Just put in return 0 to get rid of that error. Alright. Now, so I'm going to type it in first. So I'm going to say star, so that's not. So name dot equals r dot name. Is yours frozen? Can you see me moving? Can you see the writing? Fuck. Ah, it's fine. It's back again. So, how's it now with you? Yeah, Jason, you're gone. All right. Kathy, are you still there? Are you fine? Are you still disconnected? Can you sign back in again? You should. Okay. Yeah. Okay. Right now. So, what we're doing here is now this is kind of double checking we're doing here. All right. So if this dot equals r, we're turning 0, right? So if the name of, so we have again Ronnie dot compare to Rachel. All right. So if the name of the first rat is not the same as the second rat, can say the easiest thing then to say is the following. You just go return name dot. So by doing this, so if this is true, okay, that means our two rats have a different name. Yes? Okay. So if this is true, our two rats have a different name. So then all we have to find out is which one comes before which. How do we find out what name comes before what? We go name dot pair to r dot name. Okay. because if they have a different name, all right, all we have to do then is sort them. What will sort them? This guy. Okay, so that will return if that comes before that, you'll get a minus number. If that comes after that, you'll get a plus number. Yes? Everyone get exactly. All right. So we don't have to reinvent the wheel here. All right. We're using what's already there. All compare to methods at the end of the day are going to boil down to these. You're going to be comparing numbers and strings. Doesn't matter what compare to you use. It could be the most complex compare to in the world. They're all going to boil down to these guys. They're always going to boil down to numbers and strings. That's the way it is. Okay, so I'm going to put in here, if two rats have different names, then we can use compare to of the string class to see the order of strings and use this to order by the name of the rat. Okay, so it'll exit. So if they have different names, so if different names, order by names. Now if they have the same name, it's going to skip that. All right, so if they have the same name, we're going to order by age. So we do the same thing again. If age dot equals or dot age. So if they have different ages, we do the same thing again. We go return age dot compare to or dot age. So this is exactly the same thing. If two rats have a different age, then we can use compare to of the integer class to see the order of integers and use this to order by the age of the rat. Okay, so if the age of this guy is greater than this guy, it'll produce a plus number and it'll go to the end. If this guy has an age that's less than this guy, it'll produce a minus number and it'll go to the start. So minus goes before, plus goes after. All right, keep remembering that. Minus before, plus after. It's an easy enough thing to forget, believe it or not. All right. So now, so we're nearly done. Yeah. Mm-hmm. Rat of the rat class. Yeah, sure. So I said that here. So this is calling the equals method. Yeah. So this is calling the equals method of the rat class. So if the same rat and class. This is called the equals method of rat class. Returns true if same rat or if two rats have the same name, age, and weight. Now, as I said already, if you want to make sure that every rat is put in, you would have an ID on your rats. Okay? I don't. We're going to be doing squirrel class, for instance, is going to have an ID. The rat class doesn't have an ID. Right? Now, so if they're the same rat, return 0. So if they're not the same rat, then it checks the name. If it's not the same name, it's going to sort it by name. If they are the same name, it's going to skip that. It's going to go down to age. Then it's if they're not the same age, then it's going to compare them by age. However, if they are the same name and they are the same age, now you could just do this. Sorry, return rat.comparator or.weight. Now, the reason you can just do this is the following. All right. Now, this takes a small little working out. So this is where you really should have all this worked out. All right. Before you go doing coding, you should have all of this worked out in your class diagrams. It's a class diagram. Class diagram is this dude. It's a square, and the top half has your variables. Bottom half has all your methods. Okay, and you should have your methods all planned out one by one. You should have it all done. Right? You should basically know exactly what your code is going to look before you start typing it all. All right? We don't have the luxury, we don't have the time to do that. Okay? So, now if we think this through, we have checked if they're the same. All right? Now, that also rules out, let's say we have rat1 and rat2. Now, both of their names are Rory. Both of them have an age of 2. Both of them have a rate of 2.5. Okay? Now, our equals method, we've already said, if they have the same name, age, and weight, that means the return is true. So, if this dot equals r, rat1 and rat2, that will return true, so it will return 0. Alright? So that means if the name isn't the same, so if it fails this test, okay, so if it fails this test, it means that 1, they're not the same rat. It means that 2, they don't have the same name, age, and weight. They're different in some way. Okay? So, if they have the same name, if they have the same age, the only thing that can be different is the weight. So we don't have to put in a check for weight. Alright? Because we've taken care of every other possible situation. There is no other situation. Okay? That's what I mean about you need to be working things out before you just tear into it. You mightn't see that as you're tearing into it. Whereas if you have it all planned out, you will see that. Right? Now, doing diagrams, it isn't a waste of time. I know a lot of people think, oh, you're drawing little box sheets on the page. It's a waste of time. It's not a waste of time. All right? It's far easier to correct mistakes on paper than it is if you're 2 years into development and you're 24 hours from releasing the product and it all goes arse up in the air. All right? Okay? So, now, that's our compare to method done. Okay? Yeah, you could, but you don't have to. Okay? There's nothing wrong with putting it in. Okay? There's nothing wrong with putting it in, but you don't have to in that situation. All right? So put in here. If both rats are different, which we know as this dot equals or has returned false if we get to this point. Okay, so it's already failed that test. And if the names and ages are different, which again we know if we have got to this point, okay? If both rats are different, which you know as this dot equals is returned false if we get to this point, and if names and ages are different, which again we know if we have got to this point, okay, then we do not need to check if weight is different, as if it gets to this point, weight it can only be the only point of difference between the two rats. Okay, and as I said, it's hard enough to see that unless you plan all this out. Now, if you have got a framework done out for yourself, now as I said to you before, a framework is a scaffold, and one that I'm kind of familiar with is Spring. Spring it all, so you can see the way Eclipse does equals for you automatically and does hash code for you automatically. If you have a framework set up, a framework can do a lot of this work for you as well automatically. It can do your compare twos for you automatically. It can do your singletons for you automatically. It can do your immutable class for you automatically. It can do your factor classes for you automatically. Right? It cuts out, and now there is a fair bit of work involved to get it all set up. Because what you have to do, you have to set up a template for what your compare to method is going to look like. All right? Would do something like for Spring, let's say, for instance, let's say if you have 7 variables, all right, your compare to method would go through each one of those variables in order they are in your file. So if you've got name, age, weight, height, PPS number, occupation, um, wage, wage earned, and so on and so forth. You go through each one of those variables and it would try and organize them by each one of those variables in the order they are in the file. Okay, that's the sort of thing we've got to do. Now, as I say, the final 4 weeks, we're going to try and have some sort of commercial enterprise going, and that's the 4 weeks work experience. I tend to be here, okay, and 4 weeks before that, we should have the exams finished, so that's 2 months, and hopefully during that, we can set up a framework for ourselves and work it out, okay? Now, so we have a compare to method working, all right, in the rat class. So, and also in the rat class, we're going to put in a toString method so we can see it all being printed out. Okay, so let's put it in here. So I will go and override. And we got public string to string. And I'm going to say return name is name. So we're doing name first. Then we're going to do age. Then we're going to do weight. And I will do a constructor down here as well. So I go public rat takes string name, integer, age, double width. Now, if I use an int rather than a double, what I'd have to do inside the compare to method is I'd have to do something like this. So let's say let's say it was an int. Okay, what I'd have to do inside here, I'd have to go integer number is equal to none. All right, you'd have to assign the integer to, sorry, you'd have to assign the int to an integer. Okay, why? Because you can't call the compare to on an int. All right, that's why now it's no biggie to do that, I suppose, but just to be aware of that. Okay, so I'll put it in here. If we use ints instead of integer, we have to do something like the following, where we assign the int to a integer, so we can then call the compare to method of the integer class. Now there is an alternative to that as well, which I think is personally more difficult, but it's examinable. So I have to show you there's another way as well. Right? As well as using the compare to method, which I think is a lot easier. There is another way. Okay, it's using maths. No, but you could. Good. Well, well. The way you could use it is if name.hashcode is the same as r.hashcode, because it's going to be the same thing. Well, so if this dot hashcode equals r.hashcode, yeah, said that as well. But it's extra code. That does the same thing. But yes, you could use the hash code there. But to organize them, you have to use compare to. Because remember, compare to is what organizes them. Well, no, name, string, it is going to compare the two hash codes. Yeah. Okay. And let's say that one hash code comes before the other hash code. Probably isn't. I presume that's what happens. Okay. Now with these ones, it's easier. If that age comes before that age, then that produces -1. If that age becomes after that age, it is plus, and it comes after. Okay. Yeah. Well, so for, yeah. Yeah. Well, no, but you see, the thing is, as long as you implement the two of them together, then there shouldn't be discrepancies. Okay, so that's why you need really to implement the whole lot of them together. Okay, you need to implement the hash code, because the hash code is what determines in a set. Okay, the compare to method is not about comparing. It's not really about whether something is the same or not. It's about the order. Okay, so compare to is about the order, but you can't put something into a tree set or a key in a hash map unless it implements the comparable interface. Okay, right. Now, so I'll just go here. So, super, and we go this dot name, and we go this dot age, and we go this dot width, and we go this dot height, and we go this dot width, and we go this dot height, and we go this dot width, 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 and we is equal to name, this dot age is equal to age, this dot weight is equal to weight. Now, so we're going to create a couple of rats. Just see. So the easy way to check that this is working correctly and working the way we think it should be working, first of all, we are going to create two rats that are going to be different in one aspect. Okay, so rat1 is equal to new rat. This is going to be Rory the rat. An age of 3 and has an age of 12.4. Then we go rat2. Now, of course, the problem with having wrappers is this. If you have a wrapper double, it can only take a double. You get me? See that there? Whereas if it was a primitive double can take an int. Yeah? See that? 12.4. Now, after lunch, I'm going to be showing you another class where there are primitives and we're going to sort them by primitives. Okay? This is going to go again in less than a minute. So I'll just quickly do these. Rat, same name, same age. However, 11.4. Okay, I'm going to create a third rat. New rat. Now, this is going to be same name. However, it's going to have a different age. Okay, last rat. This is going to be a rat called Angela. And we don't care about the ages. We don't care about the weights. Okay, I'll quickly add you again.
Not 40 minutes, 30 minutes. Because when we added us 29 past.
Well, I think I was arsing around for a while. It said that you got the email 41 minutes ago here, and so it doesn't matter anyway. This one isn't going to last that long. So, screen 2, share, add the ball, Gmail, add you all. Yeah, you're there. So, give it 20-30 seconds. Now, so we should be all added by adding. So respond to the email there, folks. Shit. So add it again. Okay, so start again. All right, now, so I have 5 rats. Now, notice that the last rat has got the same age, or same name, same age, same weight as the previous rat. Okay? So, all these rats are different in some way. So, the first rat and the second rat, how they differ is by weight. The second rat and the third rat, how they differ is by weight. The third rat and the fourth rat, how they differ is by age. Now, sorry, it's by name. I'm corrected. Okay. Now, the priority is as well, so it's organized by name first, then age, then weight. So, if I put them in a tree set, what way is that going to display? What's going to be first? What's going to be first? Okay, so that one is going to be first. It's going to be second. Well, now we've got, so the second angel is not put in. So Rory, 3 Rorys, they're all the same. So if it doesn't go in by name, it's going to go in by age. So we have Rory 2. So that one is going to be in second. All right. Then you have the last 2. They both have the same name. They both have the same age. So then they're going to be organized by weight. So that one is going to be 3. That one is going to be 4. So it should be printing off that order. All right. So easier to find out if your comparable is working is to create a tree set. So I'm going to create a tree set. I'm going to call it rat tree. So set rat tree. What a horrible thought. 3 rats. Ugh. New tree set. Now, so I go rat tree dot add all arrays as list. So we're going to go rat 2, rat 3, rat 4, rat 5. Okay, so here's the order we said it's going to be. So that's going to be 1. That's going to be 2. That's going to be 3. And that's going to be 4. It's just a coincidence that they're in reverse order. Okay? They're not being organized in reverse order. They've been organized by name first, then age, then weight. Okay? So the next line then, I will print out our rat3. Oops, sorry, ex2. So right, so go back to these guys again. So the first at is Angela, ages 3. I haven't put in the weight. Hold on a minute now. Go back to it here. Weight is plus weight. All right. Now, so name is Angela, age is 3, weight is 13.4. Name is Rory, age is 2, weight is 12.4. Name is Rory, age is 3, weight is 11.4. Name is Rory, age is 3, weight is 12.4. So our compare to method works as we want it. Okay. So depends how you want your compare to method to work. All right. Now, ideally, when you do something like this, you probably would want to add every rat. All right. You do want to allow twins. Some rats are going to have the same name, the same age, and the same weight. All right. So you'd normally put in an ID or something like that. So in the next one, we're going to be using primitive ints, primitive doubles, and we're going to be assigning a unique identifier to every object in the class. All right. So that is going to be after lunch. By the way, it's pissing outside, so I can hear it. I can hear the trickling here beside me. So I stop that meeting, stop the share, and I will stop the video.